All right. Hello, everybody. I think we're going to get started. So my name is Victor, and today I'm here to talk about N64 Homebrew development, so how to make game for the N64 mostly. So here's going to be the plan for today. First, I'm going to talk about an overview of the N64 architecture, what's important to know when you want to make games, what are the important pieces. Then I'm going to do the same for the cartridges. There are many variations of the cartridge, so it's important to know which one you're dealing with. Then talk about the library that we're going to use. It's called Libdragon. And finally, I'm going to today start a game on stage and hopefully finish it tomorrow in the next session. So let's talk about the architecture. I would say there are three main components that you need to know when you want to start making games for the N64 that are on the motherboard. And those are the CPU, the RCP, basically the GPU, what used to display things on the screen, and the memory. So the CPU, it's 64 bits architecture. It's a MIPS architecture, and it runs roughly at 100 megahertz. So what's important here is really the MIPS architecture. If you want to make your games in C, you have to make sure your compiler can compile for the MIPS architecture. If you want to run your games in assembly, you have to use MIPS assembly. But today we're going to use C. Then we have the RCP. So it's really two processors. The first one is RCP. It basically does the calculation, the transformation. It's also perform the audio functions. And the other side, the other processor inside, it's what we call the RDP. This one basically really outputs your sprites or your things on the screen itself. And one fun fact in the game GoldenEye, in the mission silo, there is one objective where James Bond has to pick up 4 circuit boards, and I'm not sure you can see here, it might be too small, but basically two of those circuit boards that you have to pick up in the game are actually named after some internal pieces of the N64. So I thought that was a nice touch from the game GoldenEye developers. And then let's talk quickly about the memory. This one is fairly simple. It's 4 megabytes on the N64, and you can double that to 8 if you had the expansion pack, so the little red thing that you put inside the N64. So at most you have 8 megabytes of memory to use with your games. Now let's take again a quick look at the cartridge. Again, on the cartridge, there are a few important chips to know, mostly the ROM chip and the save chip. So here, this picture, it's one of the most simple cartridge because it has a very small ROM chip and you cannot save on this cartridge, so it's fairly simple. Let's quickly go over every chip. So for the ROM chip, it can go from like one single chip. For example, Dr. Mario, the game is on like 4 megabytes, and GoldenEye is on 12 megabytes. And it can go up to 64 megabytes. Some cartridges, mostly the ones that are later in the N64 life, are using multiple chips. So this picture, for example, is from Resident Evil, and it's using 2 chips of 32 megabytes. So basically what it means is when you create a game, the biggest size you can have is 64 megs, and that's it. And so yeah, you have to make sure your game fits in 64 megabytes. If you use the flash card, that's not an issue, but if you plan to burn your game in an actual cartridge, obviously the 64 megabytes cartridges are more expensive than the 32 and the 12. So it's always good to know what kind of cartridge you want to use at the end, so you can keep that in mind when you make your game. Also, what we can see on those pictures is how the cartridges evolved from, this one is GoldenEye, so one of the first game, to Resident Evil, one of the latest game. It's very different. It's funny to see how the PCB and the circuit board improved over the years. Next, the save chip. Again, you have in N64, it's very odd. You have many ways to save your games compared to, I don't know, a PS1 where it was only the memory card. On N64, you have many choices. One of the choices, the first one, would be to save on your cartridge directly. And for this, you have several methods. One of them is to use an EEPROM. What you need to remember for this one is it's tiny in size. So this one is, again, it's GoldenEye, and it's only 4 kilobytes, the entire save. But it was very cheap back in the days to get something. That's why many games are using that, because it was cheap at the time. Then if you want more space, you can use something called the SRAM. This one is much bigger, so in this example, it's Resident Evil 2, and it's 256 kilobytes. The main downside on this one is it needs a battery next to it to keep the data inside the memory alive. And so what it means is at some point in the future, the battery will die and all the saves will be gone. And then you basically need to open the cartridge, put a new battery, and then you're good to go. That's also what's the memory pack that you put at the back of the N64 controller uses. It also has a battery inside, so beware, the saves are going to disappear at some point. And the last one, it's called Flash RAM. It's much bigger. This one is 1 megabyte, but it's expensive, so not a lot of games use that. And to give you a rough idea of what games use what. So the controller pack, again, the stuff you put at the back of the N64 controller, is widely used. More than 200 games are using it. And then, you can see at the bottom, EEPROM was also quite popular. Again, flash RAM on the right, not that much because it's expensive. And also, funny enough, you have 21 games on the N64 library that cannot save at all. They cannot save on the cartridge. They cannot save on the controller pack. So, yeah, it's also an option not to save your game. And then I wanted to quickly mention a few other oddities that you could find on a cartridge. So this is one example. Here you can see a big battery, but it's actually not used for the save. This game is Animal Crossing that was released on the N64 in Japan. And it actually uses a real-time clock, so when the game is not plugged in or anything, it still continues counting the time, and you can do stuff. The game uses the passage of time to change inside. So there is a battery, but it's not used for save. It's used for that chip that is a battery. And one of the oddest, I would say, cartridge for N64 is also a game released in Japan. And this one basically has a built-in modem directly inside the cartridge. So back in the day, you could take your phone cable, plug it in the cartridge directly, and you could do online play with other people. So yeah, some people got really creative with cartridges, and that's funny. I think for what we do right now, most of the people that create games, they run them on the flash card. So you can make your games up to 64 megs of RAM, and you can save pretty much how you want. You can choose what save file to use. But again, if one day you plan to burn your game into an actual cartridge, you need to be careful of what save method you used, what is the size of your game, and things like that. Now let's do a quick overview of the library. So the library itself, it's called Libdragon. It's completely open source. It was created by Jennifer Taylor, and it's written in C. You can find documentation online. And basically the two things very important to understand is, first, there is no proprietary code inside the library, meaning it doesn't rely on the Nintendo SDK. It's completely free, it's completely open. You could make a game and you could sell it using that library, and you would be fine. It's not using any code from Nintendo or anything. So I think that's great that that community effort came to life, and that anybody can make games without having to download some stuff from Nintendo. It's completely free. The one I would say downside of this is that library was made by reverse engineering an N64, let's put it that way. So basically what it means is it really expects either a real N64 or an emulator that works perfectly, like as good as the N64. That means the games you produce with that library, you cannot use any emulator you can have on your computer. You have to use some specific emulators that are very, very accurate. So they are a bit slower to run, but they work perfectly. So what I usually do is when I do the coding, when I code, I have this emulator to do my tests. And toward the end, when I want to really test the game, I actually put it on a flash card and test on real hardware. We're going to do that tomorrow. Today I'm going to stay on the emulator and on the laptop, and tomorrow we'll move the game to a flash card. So, and that library is composed of several subsystems. I'll go over them right now here, and then when we do some live coding, I'm going to explain more. Basically, you have the audio subsystem. So, as the name states, it's used to play sounds. So you just, when you initialize it, you say what frequency you want to use, and that's it. You have the controller subsystem. So again, this one, the name is fairly simple. It's it interacts with the controller, so you can, of course, get what buttons were pressed. You can save on the controller pack. You can turn off and on and off the rumble pack. If you have forgot the name, but the attachment that came with like Pokemon Stadium to put Game Boy cards in, so you could also interact with those. So it's a fairly extensive controller, and it's also saves on the card itself. That's the controller that you use. Then you have the display. So you have three methods of displaying things on the screen. First, you have the console. This one is fairly basic. It's just white text on black background. Yeah, it's mostly used for debugging and stuff like that. You have the graphics way. So this one is software-based, meaning it's very small. Very slow, but it's very easy to use. And you have no limitation on sprites. So if you want to display an image that is quite big, you can use the graphics controller, and it's going to display it for you. It might take some time, but at least it will display it. And to finish, we have the ARDP, to come back to what I was saying earlier. So this one is hardware-based. It's very fast, but I would say one of the downsides is that you have a limit for the sprites, for the image you want to display. That is 4 kilobytes, so it's only 64 pixels by 64 pixels. Meaning if you want to display a larger image, you have to split the image yourself and like piece the things together on the screen next to each other. So it's slightly more code, but again, it's much faster. Then you have the timer one. So again, this one, you can use either start one-time timer. For example, okay, in 5 seconds, I want to do something in the game, so ping me in 5 seconds. Or you can start a continuous timer. One example, very basic, is when you do a game, usually you have a press start button on the main screen that blinks. So you could use that to say, okay, every 1 second, ping me every 1 second, so I can change the state of the press start string. And lastly, you have the file system one. So this one is basically allows you to open directories, list files, open and close files that are inside the ROM itself. So, for example, again, if you want to display images, you would have inside the cartridge, technically, you have the binary on one side that the N64 executes, and then you have all the other images that are somewhere else on the cartridge. And with that subsystem, you can go find that image, open it, and then use it in your code. Let's very quickly look at the skeleton of a very simple game on N64, and after that, I'm going to switch to actual code. So how we would start doing this? First step is to import the library. So again, the library is in C, so you just have to import the header file. Then I would open the main function. Then I would initialize all the controllers I plan on using. So here, the first is always init interrupts. It enables hardware interruptions. It's needed for pretty much every subsystem. So it's always the first line of your code. And so there, in this example, I initialize the audio subsystem with the most well-known frequency. I initialize the controller subsystem because we're planning to use the controllers to play the game. Initializing the display with specified resolution, the file system, the RDP to display things on the screen using hardware, and then the timer. So it's just an example, but basically you init all the subsystems you need. And then you're going to run your main loop. So that loop is going to run for every frame of the game, forever basically. And so usually you get the state of the controllers. With what happened with the controllers, you update your game state. Then you wait for the display to be available to write on it. Once you have the display object, that disk, you can use it to update it. I don't know, change the background or stuff. And once it's done, you can actually show the display on screen. And if you want, you can write some sounds, some audio at the time. And then that's it, and it's going to run forever. So let's actually start building a game. So today we're going to try to do Minesweeper game because it's fairly simple and I think it's a good example. So the plan would be today to try to use only colors and simple things, and tomorrow to actually use the file system and use images to make it nicer on screen. So the tools I'm going to use on the left side, so to develop the game, it's basically any text editor. Myself, I'm using VS Code, but any text editor works. And then, as I said earlier, one emulator that works perfectly, that is very accurate. In that case, I'm using N64. And tomorrow, to test the game on the cartridge, I'm going to use an EverDrive, so it's a flash card where you can put ROMs inside. Recently, they released EverDrive and other brands. They released flash cards that are great, that have USB port in the back, where you can plug it directly to your computer, and so you can make your game, and when you want to test, you can push your game to the cartridge directly, and it works great. You can do remote debugging and stuff. And so that works great. Unfortunately, I have an older version of the flash card, so I don't have that USB port. But what I did to speed up things, because if you don't do anything, you have to shut down the X64, remove the SD card, put it on your computer, copy the ROM. It can take forever. So what I did is I'm using here at the bottom something called a Flash Air. It's basically an SD card that has Wi-Fi built in. And so, meaning that I can be on my laptop, the N64 can be further away, and I can remotely push my game to the SD card without having to unplug it or anything. So it's much faster, and I think if you don't have the fancy flash card, I think it's very good to do that. It's fairly cheap, the Wi-Fi SD card, and it's a great way to push your games to the console without having to unplug anything. All right, let's switch to editor. So please, anyone, let me know if it's too small or if you have any question or anything. So basically, I opened pretty much the skeleton I just talked about earlier in the slides. So I included the library. When I initialized the display, the main two parameters are the resolution and basically what the size of every color you want to use. So it's called bit per pixel. Here it shows 16. That means you can have 5 bits for the red, 5 bits for the green, 5 for the blue, and just 1 bit for is it transparent or not. So basically, if you use, for example, 32 bits, You can display more colors, but everything will take more space. So I think 16 it's a good trade-off. You can still, with that combination of 555, you can still display a lot of colors, and we don't plan on really using transparency that much. So I think that's good. The next argument, honestly, I do not remember. I always use the same, so I would have to refer to the library to check. Then I initialize the display, and that's it. I'm not doing anything. So here, if I try to make the ROM, so here at the bottom, it's going to build, and I can quickly show what's going on. If we look at the makefile, again, to be very quick, so to create the ROM, you need a binary, and you need the file system image. To create the binary, it's going to take all the C file, compile them like any binary basically. And for the file system image, it's going to use a folder on my laptop, and it's going to get everything that is in that folder and make it a file system image. And after that, once you have those two elements, again, you call a tool that comes with the library that is going to take basically your binary, your file system image, and put it in the ROM. And that's it. So while I was talking, it built. The ROM doesn't do anything, so it's very fast. And then what I can do is basically this is going to run the emulator with the ROM we just made. So if I start that, I have a black screen because the ROM is obviously not doing anything. But that's how we're going to test the game. So let's get started. So I think one of the first things we want to do as soon as we initialize the hardware interface is to basically say where can the hardware, the RDP subsystem interact with the screen. And so to make things simpler, we're going to say RDP can use the entire screen, so it can display stuff everywhere. So to do that, just have to call this function. So this say, okay, let's use the entire screen. And then just to make sure everything works, we're going to do something very, very simple. We're going to first put a white background and then put the title of the game up. If I go back to the slides, there are a few things I want to mention. A few functions I'm going to copy paste because they are useful and I use them all the time. So this one, for example, displays some text on screen that is centered. So the function at the bottom, this one, graphics draw text, is a function that is in the library, and that small function that I'm going to use just make the calculation for you automatically to center the text. So I'm going to copy paste this one. So every function that starts with graphics is going to be using the graphics subsystem, so the software based. But to write text, it's very easy. And then there is another big function that I want to copy paste. This one is to draw a rectangle on screen with a color. And so what this function is doing is basically making sure the RDP subsystem is in the right mode. Then it's going to wait for the RDP to be ready to receive new commands. Then it's going to set the color. And finally, it's going to draw that rectangle. This function that is in the library basically usually takes the top left corner and the bottom right corner. And since, I don't know, I don't want to do those calculations all the time, this function I'm going to copy paste just takes the top left and then the width and the height, and just do the calculation for you. So that's much easier to use. And finally, I'm going to copy paste a few basic colors that we're going to use in the game. So it's just using a function, make color from the library, and you give it like red, blue, and green. Red, green, blue, and the alpha. This function uses either you are in 16 bit per pixels or 32 bit per pixels. That's why you have to call that function in the program. So let me just open this and copy paste everything I just mentioned. All right, I'm going to copy on top. So here's everything I just copied. So yeah, what we're going to do is first we're going to put a white background. So here I have the display ready. So what I'm going to do is I'm going to attach the RDP to the display. So I attached the display. Then just before actually showing stuff on screen, I have to detach. And so while I'm attached, I can use RDP functions to update the display. So in that case, I am going to draw a big rectangle. It's going to start at 0, 0. It's going to be as wide and as high as the screen, and it's going to be white. So here in this block, we are attached to the display with the hardware subsystem. So between those two lines, everything hardware-based should happen. And once you're done with the hardware subsystem, you can then use the graphics subsystem. And so here I am going to draw some text. Again, I'm going to center the text. So I'm going to give it the display. I'm going to give it the middle of the screen and 6 pixels from the top of the screen. And then I'm going to name the game Minesweeper 64. And so I'm going to compile, and then just after that, I'm going to run the emulator. I already made a few mistakes. So maybe I forgot to include a library. And so I do have a white background, and one thing I forgot is before printing the text, you need to say the color of the text actually. So here I'm going to graphics, and I think it's set color, and so you have to give the foreground and the background color. So let's use dark gray as background and nothing. Sorry, so the text will be dark gray and there will be no background. So if I run again, okay, the text is centered and it's displayed. Thank you. Thank you. All right, so now let's do something a bit slightly more complicated for the mind. Yes?
So the 0 that you put after the dark gray, is that like the color information for the background?
Yeah, that will be the background. For example, if I put red here and I recompile. Oh. Yeah. So. All right, so let's start working on the board itself for the Minesweeper. So first, let's define a type. So the type of one cell. So a cell, it's going to be basically a Boolean to know is it visible or not. By default, everything would be hidden. You need to click on them to make them show. So is it visible? Is it a bomb? Oh. And then the number of cells around it that have a bomb. You know the number when you play Minesweeper, most of the cells it's like 1, 2, 3, 4. So let's use a number. And then let's name it. So here I use 3 different variables to make it simpler to understand. Of course, when you you want the game to be as small as possible and as efficient as possible. So you could do everything with just an int, for example. You could define that, okay, 1 to 8, it's the number of close by. If you happen to be -1, it means you're visible. If it's -2, it means it's a bomb, stuff like that. You could find more complicated and more shorter way to do it. I'm just using 3 different variables, so the code is easier to understand. All right, so let's create the board. So the board in our case is going to be 10 by 10. And we're going to create a function to initialize that board. So init board maybe sounds good. And so in this function, what we want to do is first set the board to completely 0. So everything is hidden, there is nothing, it's a brand new board, fresh board. And then we want to generate bombs and put the bombs inside. So I'm going to create the function. So yeah, at first I'm going to just erase the content of the board. So memset just puts what you want. So in my case, it's just put zeros everywhere. And it's going to be 100 times the size of one cell. All right, so here the board is brand new. Fresh, clean, and full of zeros. Then we're going to place bombs inside that board. For example, eight bombs. So 4. So we're going to run that for 8 times. Basically, what we want to do is we want to generate random positions for the bomb. So what we are going to do is basically get a random number that is between 0 and 9. So it's inside the board. Yes?
I think you mean
yeah, so yeah, right. So you do that for X and you do that for Y, and then the idea is first you check if inside the board at that position, so if it's already a bomb, we need to find we need to retry somewhere else basically. So what we do in that case is we just decrease our tries and we just try again. That's the easiest way. And then if it was not a bomb, you actually make it a bomb. So that's would be the very basic idea. So here, one thing we need to understand is, at this point, the bombs, every time you start the game, it's going to be always at the same place, because we need to initialize the way random is chosen in the N64. If you don't initialize it, it's the same all the time. So to do that, in C, you use a function called srand that, srand, and you give it something that is different every time. And so in our case, we're going to give it use a timer. So just give it a tick of the timer that is going to be different every time because the clock is different every time, and that should make everything random. And to use the timer, you need to initialize the timer subsystem. So just do an init timer. I think it's timer init actually. All right. So here we have bombs in the board. Let's try to display a board to see what it looks like. So we're going to create a function that is going to draw the board. It's going to take the board again. So here it's going to be quite simple. It's going to be, we're going to go over all the cells. so 10 for X and 10 for Y. And then, depending of what's inside that cell, we're going to do different things. So, I think by default, we're going to, for each cell, we're going to display a black square, and then at the same space, a slightly smaller square that is a different color. So it's going to look like a grid, and it makes things nicer. So I have the position written here because it's hard to remember. So we're going to, again, as I said, write a rectangle. This rectangle is going to start at, so from the left of the screen, let's say we're going to give an offset of 60 pixels, so it's centered, and then it's the number of X, and each square is going to be 20 pixels in size. For the top, we're going to have an offset of 20, and basically give the same 20, and then the size, everything will be 20, and black. All right, and then basically do a quick if. If it's a bomb, we're going to display some red cell. If it's not a bomb, we're going to display some light gray. Yeah?
Just a quick question regarding C. Do you have to worry about order of operations, such as will it always try to read left from right when using addition and multiplication, or can you kind of just know that it's going to try to multiply first before adding? Yeah,
no, it's going to try to multiply first. So you don't, the plus 60 could be on the right, it doesn't matter. And so if we look at our board on X and Y, if it's a bomb, we're going to display at the same space something that is going to be red. And so basically, let me remind, so we're going to be, the cell itself is going to be 4 pixels less. And I think if I remember here I need a +2. I mean, we can always adjust, but basically I want to display something that is 4 pixels smaller, so I have to move it. Anyway, I think it's going to make sense when we run the game. And so if it's not a bomb, let's put, I don't know, light gray for, why not? And then, so we want to display the board. Again, the board display, it's using all RGB, so hardware things. So we have to do it while I'm attached to the display. I have to do it here, otherwise, if I do it here, that background will erase everything I did. So I have to do it after the background. And I just do that. Let's see. What did I miss? All right, I forgot. The SRAM is in the library that I forgot to include. I think it's STPD.
Your SRAM was after your init board.
Sorry?
Your SRAM was after your init board? So it's probably the same every time.
No, it should be at the beginning. Oh, sorry, you're right. So that's correct. So this should be done before we use. Correct. Thanks. It should be done here. So basically, that's what we have right now. So again, for every cell, we display a big black square, and then on top of it, we display a smaller square, gray if it's empty, or red if it's a bomb. So now that I fixed the SRAM, if I recompile and rerun, it should be in a different position every time. So we have the basic board. One thing we could do right now is actually fill out the numbers of near to know when a cell is next to a board. Actually, I think we are almost out of time, so I think I'm going to stop here for today and do the near and the rest and tomorrow. We have 5 minutes if you do have any questions.
Do you have this example online anywhere?
Yeah, this example is on GitHub. tomorrow, once we're done with here at Portland, I'm going to post the link tomorrow on the slides. But yeah, it's online with different levels. It's split in like day 2, day 1. So yeah, anyone decide?
If you want to develop homebrew seriously, do you want to know MIPS as well as C?
I mean, unless you plan on really doing assembly, and here it's completely different. MIPS assembly, it's completely different from x86 you would have on your computer. Otherwise, I would say no. As long as you write in C, the compilator is going to do pretty much everything for you. So, in very rare case, I had to do stuff with very MIPS specific, but probably no. Yeah.
I'm wondering on the art side, if you are wanting to put in a 3D assets, is there like a program that would work well for that, or just anything?
No, you really have to do everything by hand. There is no framework or anything. So even displaying like a triangle that rotates, you have to do all the calculation yourself and stuff. So the only asset you put are 2D sprites, 2D images.
I see.
Yes.
Is there a feasible way to be financially stable and do homebrew development, or is it really only a hobby?
I think it's definitely a hobby. I mean, you do see some games coming out that have publishers, so they have physical releases. I think it's like the N64 was not the most popular console, so only the games I see that makes, I don't even know if it's money, but at least that seems to be successful are mostly on like NES or Super NES. So I think it's a hobby. Yeah.
You said there are 2 graphics modes, one with software-based, much slower, and hardware one.
Yeah.
Can you mix and match those 2 to exceed the sprite limit?
Yes. I mean, here, technically, that's what we're doing because the text itself is rendered using the graphics one. So you can mix and match. It's just if you do something that can't count the frames, as soon as you stop using the graphics one, the frames rate goes up. But, I mean, usually it's fine for stuff like that to do it. Again, the plan tomorrow is to completely remove the graphics one and only use the hardware one. All right, then. Thank you everyone for coming. And so tomorrow I have a session.